Greetings everyone, and today we are going to discuss about the hybridization structure of tetrafluoride and methane. Previously we discussed that there are bases on which we give the geometrical shape of sp2 and sp3 hybridization. Now here we can say that the position of hybridization can be determined in such a manner that here sp2 is having trigonal shape 120-degree angle, sp3 having tetrahedral shape 3D shape, not a coplanar shape which is having its angle 109.5, and sp2 is having 2D shape, one planar shape in which all the three orbitals are on a single plane. Now in this case there are three methods in which we classify their structure. There is dot structure. Third, there is first there is dot structure. Second, there is a presence of solid line structure, dot structure, in which we represent the bonding by dot. Solid line structure, also known as graphical structure. Dot structure, also known as electronic structure. Apart from which there is hybridization of structure, hybrid orbital structure. Hybrid orbital structure has the following aspects: that here it is central atom, boron, while there are surrounding atoms and the valence electrons of the central atom surrounding atoms participate in the chemical bonding, whereas there is the hybridized orbital which are possessed by the central atoms. First, let us look at the boron. Boron is basically having the atoms in such a manner that here, for suppose this is boron, and here, as you can see in the boron, there is the sp2 orbital, sp2 orbital, sp2 orbital, hybridized orbital. On the other side, fluorine is having its outermost pz orbital. That pz orbital forms a bond. It forms a chemical bond with sp2 hybridized orbital, or the central atoms hybridized orbital, due to which it collectively forms a bond which is known as a sigma bond. Due to which it forms a sigma bond. As this is so, how many sigma bonds are there? There are three sigma bonds over here, and that is collectively forming three sigma bonds. And this is a bond which is present between sp square p. This is a bond present between sp square p sigma. Now, how is it sp square p? Because there is sp square hybrid orbital and atomic orbital. Secondly, there is hybridization of CH4 methane. Methane is having this structure in which there is a tetrahedral structure, 3D structure with non-planar structure, and here the 109.5 is the bond angle in such a manner that here this is sp3, this is sp3, 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 and this is a bond formed between sp3s, which means sp3 of the central atom carbon with hydrogen as a surrounding atom forms a bond which is sp3s bonding. sp3s bonding, and here the central atom is chosen on the basis of number of molecules, and if there is less number, for suppose in CH4, C is having the least number. C is having least number than hydrogen, due to which we count C as a central atom, while H4 being the highest number, high number in the molecule, will be on the sides or the surrounding atoms. In that case, this is how the structure is formed. Now, this question arises that which bond is stronger, sp square or sp square p, sp2p bond, or sp3s bond? So the answer is sp2p bond. Why? Because sp2p bond is having p atomic orbital. We know that p atomic orbital is basically having a dumbbell shape, elongated shape. P orbital is having a dumbbell shape and elongated shape, and that dumbbell elongated shape, when it forms a bonding with the sp2 orbital, that's being highly elongated, causes to form stronger bond. It causes to form a stronger bond because it is elongated. As it is elongated, it causes to cause more overlapping. As there is more overlapping, there is less energy produced, and there is more stronger bond. On the other side, sp3s, there is s orbital. S orbital having no orientation, due to which an s orbital forms a bond with sp cube. Suppose this is sp cube. When it is forming a bond, sp3 forming a bond with s, and S basically having not an elongated shape. If it is not having an elongated shape, then it does not fully fits in the sp3 orbital, which means in order to connect both of them, attach with each other, uh, mix them each other, bond them with each other, they require this structure. So the s orbital is just like a spherical shape, so it is having less amount of bonding, which means weaker bonding exists, high amount of energy exists. This is the structure, because here the S is round and it forms together with sp3. It causes to, uh, as it is having S or S a spherical structure, it is hard to attach, it's hard to fix up, mix up with the hybridized orbital. So in this case, this is hybridized energy. So this was about this video. Hopefully we'll meet